In this video, I'll be going over double angle and half angle formulas. So what we have here in this first one, sine of 2a, what this means is a is an angle. And what we are saying is that we're doubling that angle. Now, one way to think about this is if we are doubling something, that's the same as adding it to itself. And we can expand this sine of a plus a using the sum formula. So we're going to say sine of the first times cosine of the second. But since they're both a, since both angles are a here, we get a in both positions. And then plus sine of the second, cosine of the first. And so if we notice, these are both like terms. So we're going to say 2 sine a cosine a is equal to sine of 2a. So this right here is what sine of 2a is equal to. All right, we have a similar identity for cosine, the double angle for cosine. And let's derive this in the same way. Now, the sum formula for cosine is cosine of the first times cosine of the second. We reverse the operation, minus sine of a cosine of a, I'm sorry, sine of a, sine of the first times sine of the second, but they're both a. So this is cosine squared of a minus sine squared of a. So this is one of the versions or forms of the double angle for cosine. Now for cosine, which is different than the double angle for sine, the double angle for cosine, we have two other valuable forms that we're going to see here. And they both of these other forms come from the Pythagorean identity. Okay, so what I can do is if I solve the Pythagorean identity for cosine squared of a, we get 1 minus sine squared of a. What I'm going to do is I'm going to substitute this in for this cosine squared of a. And what we get is 1 minus sine squared of a minus sine squared of a. So I have two of those. So another form that the double angle for cosine takes on is 1 minus 2 sine squared of a. So that's a second version of this. And then if I take the Pythagorean identity again, and this time solve for sine squared of a, I get 1 minus cosine squared of a. And what I can do is up here, in place of sine squared, I'm going to substitute in that 1 minus cosine squared of a. Okay, so we're going to see that I have cosine squared of a minus 1 minus cosine squared of a. Distributing this 1, I'm going to get 2 cosine squared. Let me put this in blue. 2 cosine squared of a minus 1. So that is a third version for the double angle of cosine. Now, when we're working with these, we're going to use whichever one works in the context of the problem. So sometimes we'll use one versus the other. Okay, lastly, we have the double angle formula for tangent. And we're just going to derive this from the sum formula for tangent. And remember, this is just tangent of the first plus tangent of the second divided by 1 minus tangent of the first, tangent of the second. And this is going to simplify into 2 tangent of a in the numerator divided by 1 minus tangent squared of a in the denominator. All right, so there are the double angle formulas for tangent, cosine, and then sine. So we'll use these in a few different examples in this video. First, let's verify this identity. So what we notice right here, 2 theta, that is 2 times some angle. So we have the double angle formula for sine right here. So what we're going to say is we're going to replace this with that double angle for sine. So 1 plus 2 sine, the angle is theta here, cosine theta is equal to, and then on the right hand side, I'm going to expand this out because this is getting squared. This is sine of theta plus cosine theta times sine theta plus cosine theta. Okay, so on the right hand side, I'm going to distribute this out, sine squared of theta plus sine theta cosine theta plus sine theta cosine theta plus cosine squared of theta, and cosine squared of theta plus sine squared of theta, that's the Pythagorean identity, and that's going to equal 1 here. And then this and this, those are like terms, so I can combine those. So the 1 from the Pythagorean identity is going to be 1 plus, and then I have 2 sine theta cosine theta. And that is what is on the left-hand side. So we've got it. All right, scrolling down here, the next thing in this video, the next types of identities or formulas for us to work with are the half angle formulas. Okay, and so if we notice down here, now we're taking some angle, in this case it's x, and we are dividing that angle by 2. So how do we derive these? So let's start with cosine of 2x. So I have the double angle formula for cosine, and I'm going to use this version, 2 cosine squared x minus 1. And what I can do is, if I divide both sides by 2 here, actually I want to solve for cosine squared, so I'm going to add 1 to both sides. So I get cosine of 2x plus 1 is equal to 2 cosine squared of x, and then divide by 2. We're left with cosine of 2x plus 1 divided by 2 is equal to cosine squared of x. Now if I take the square root of both sides, come up here, we end up with plus or minus the square root of cosine of 2x plus 1 divided by 2, and that is equal to cosine of x. Okay, and now one thing we can notice here is I have a double the 2x here, and I have x over here. So on the left-hand side, I have twice that angle, and on the right side, I have just the angle. So what I'm going to do is I'm going to do a substitution. We're going to say let x equal y over 2. Okay, so on the right hand side we're going to have cosine, in place of x I'm going to have y over 2. On the right hand side, well, plus or minus the square root cosine of 2 times x. Well, if x is y over 2, that's just going to be y here. Okay, so that's just a little bit cleaner of a formula, what's under the square root there. Okay, so what this is saying is, again, if I have some angle that I can divide by 2, we can just use this on the left-hand side as a shortcut. So let's fill in this left-hand, or these formulas over here on the left. So this first one is going to be plus or minus the square root of cosine of x plus 1 divided by 2. Again, I'm using x here because since I have x over here, I want x right there. Sine of x over 2, well, this one is quite similar. What I should say is how we derive this is quite similar. And actually, I'm going to change how I wrote this. Instead of cosine of x plus 1, I'm going to write this as 1 plus cosine of x over 2. And the reason is because the half angle for sine is 1 minus cosine of x over 2, just so that these are consistent. 1 plus for cosine, the half angle for cosine, 1 minus for half angle for sine. And then for tangent, it's plus or minus the square root. Remember, tangent is sine over cosine. So this is the sine, which is 1 minus cosine x over 1 plus cosine of x. All right. And then the last thing to mention is how we have these all as plus or minus. We will make a decision on whether it's positive or negative. Plus or minus depends on the quadrant of x over 2. So if that quadrant is, let's say it's the second quadrant, and I'm doing half angle for cosine, well, cosine is negative in the second quadrant, so I'd use the negative there. So you just need to determine which quadrant the angle that we're talking about, x over 2, what quadrant that's in, and then determine whether sine, cosine, or tangent is positive or negative in that quadrant. Okay, let's look at an example of this. Find the exact value of cosine of 157.5 degrees. Well, the first thing to notice is that 157.5, that is half of 315 degrees. Okay, and what's special, I guess, about 315 is that 315 is on the unit circle. So we're going to say that our x value here is 315 degrees. So when we put this into the formula, cosine of x over 2 is equal to, well, our formula from up above was plus or minus the square root 1 plus cosine of x divided by 2. Okay, and so again, we want to come up with this fraction so that the numerator is a value on the unit circle, because we can evaluate that easily. All right, so plugging this in, cosine of 315 divided by 2. Well, what quadrant is 157.5 degrees in? Well, that's greater than 90, less than 180, so that's quadrant 2. And cosine is negative in quadrant 2. So we're going to say this is the negative square root here of 1 plus cosine of x. Well, x is 315 divided by 2. Simplifying this, we're going to get negative of 1 plus, well, cosine of 315, that's down here, and that is positive root 2 over 2 comma negative root 2 over 2. Cosine is the x coordinate, so this is root 2 over 2 divided by 2. And we can leave it like that, but we can simplify because we really don't want to have this fraction in the radical. We don't want a complex fraction. Oh, and this is negative in front. So negative of, well, what we can do is I can multiply the top and bottom here by 2 over 2. So when I multiply this numerator by 2, we're going to get 2 plus that 2 and that 2 cancel. So 2 plus root 2 divided by 4, and that's all in the square root. And then I can do one last thing. This 4 in the denominator is under the square root symbol, so the square root of 4 is 2. So that can be written outside of the radical, and then 2 plus square root 2. So that's, I think, as simplified as we can get, although this is an okay answer up here. All right. The rest of this video is just a handful of examples using these identities, the double angle and half angle, and then also using some of the identities we've seen in other videos. So let's just go through. This first one says simplify the following expression: 2 sine of 15 degrees, cosine of 15 degrees. So here it's kind of like we're using the double angle formula for sine. Okay, and doing this, well, we're saying that theta is equal to 15 degrees here. So if I plug 15 in for theta in all those positions, this is sine of 2 times 15 degrees, and then 2 times sine of 15 degrees cosine of 15 degrees. Well, on the right-hand side, 2 times 15 is sine of 30 degrees, and I know what that is. That's equal to 1/2. So 2 sine of 15 times cosine of 15 degrees is equal to 1/2. So that would be 1/2 here. Next up, if cosine is equal to 2/5, cosine of theta is equal to 2/5, and theta is in quadrant 1, find the exact values of sine of 2 theta, cosine 2 theta, and tangent of 2 theta. Okay, so how do we do this one? So one thing I like to always do is see if I can get a diagram of this. So cosine is in quadrant 1. When we draw this, theta is always this angle down here at the, near the origin. Cosine of theta is 2/5. Cosine is the adjacent over the hypotenuse. So we can solve for this value. We'd say 2 squared plus y squared is equal to 5 squared, which is 25. 4 plus y squared is equal to 25. Y squared equals 21. So square root 21 is what this missing side is. Okay, so we want to come up with the double angle for this. Well, for cosine 2 theta. So cosine 2 theta, how you want to do this is use one of the identities for the double angle. And I don't think it really matters which one we use. I'm going to use this one, 2 cosine squared of theta minus 1. Okay, so let's see what we have here. Well, this cosine squared of theta, I know what cosine of theta is, right? We already were given that. It's here. So that means that cosine squared of theta, if I square both sides, that's going to be 4 over 25. So I can substitute this for 4 over 25. So cosine of 2 theta is equal to 2 times, 2 times 4 over 25 minus 1. And I get 8 over 25 minus, well, if I get a common denominator, there's going to be 25 over 25. And this just comes out to negative 17 over 25. Okay, and that makes sense because if theta is in quadrant 1, if I double that, it's likely to be in quadrant 2 or quadrant 3. So cosine is negative in quadrant 2 or 3. So that's how that one's going to work. Sine of 2 theta. The formula for sine of 2 theta is 2 sine theta cosine theta. Okay, and from the triangle, we already have we already have cosine of theta. Cosine of theta was 2/5. Sine of theta is opposite over hypotenuse, so square root 21 over 5. Multiplying these out, I get 2 times root 21, so 4 square root 21 divided by 25, and that's sine 2 theta. And then tangent of 2 theta, that formula is 2 tangent theta divided by 1 minus tangent squared of theta. Okay, so tangent of theta, well, tangent is opposite over adjacent, so 2 times square root 21 over 2 divided by 1 minus tangent squared, so root 21 over 2 squared. And then simplifying this, in the numerator, those 2's cancel. I'm left with square root 21. In the denominator, we have 1 minus square root 21 over 2 times square root 21 over 2 is just 21 over 4. This one's taking some time here. Getting a common denominator, this is 4 over 4. So what we are left with is square root 21 divided by 4 minus 21 is negative 17 fourths. and multiplying the top and bottom by 4. I get 4 square root 21 over negative 17. So kind of a long problem. And I just realized a quick way to do this one would be to realize that tangent of 2 theta is equal to sine of 2 theta divided by cosine of 2 theta. Since I've already figured out sine of 2 theta and cosine of 2 theta, well, sine of 2 theta was up here. So this is going to be 4 square root 21 over 25 divided by cosine of 2 theta, which is here, negative 17 over 25. The 25s can cancel, and we're left with 4 square root 21 over negative 17. And that matches what I found here, but probably a little bit quicker of a way. We don't have as many messy fractions. All right, couple more examples here. So find the exact value of the following. Cosine of 105 degrees. This looks like a sum or difference question. Remember, we want to split up 105 degrees to be 2 angles that add or subtract to 105. And I'll do this as a difference, 150 minus 45 degrees. So this is going to be cosine of the first times cosine of the second plus sine of the first, 150 degrees times sine of the second, and then we just evaluate this. So cosine of 150, that is quadrant 2, that's a negative root 3 over 2. Cosine of 45 is root 2 over 2, plus sine of 150 is 1/2. Sine of 45 is root 2 over 2. Putting this all together, negative root 6 over 4 plus root 2 over 2. That can combine to this. Negative root 6 plus root 2 over 4. And made a mistake here. This should be a 4. Okay, so there is our answer for that one. Next, we have sine of negative 5 pi over 12. This is also a sum or difference question. We can come up with 2 angles that add or subtract to this. Let's see. I think if I do 4 pi over 12 minus 9 pi over 12, because 4 pi over 12 is pi over 3, that's on the unit circle. 9 pi over 12 is 3 pi over 4, that's also on the unit circle. And that adds up to negative 5 pi over 12. So what I'm going to do is I'm going to just write that with those angles that are on the unit circle. And then we'll just expand. So this is sine of the first times cosine of the second minus the sine operator stays the same. Up here, for the cosine, the cosine operator flips. So sine operator stays the same, and then this is sine of 3 pi over 4 times cosine of pi over 3. Simplifying these out, sine of pi over 3 is root 3 over 2. Cosine of 3 pi over 4 is negative root 2 over 2. Minus sine of 3 pi over 4 is positive root 2 over 2. Cosine of pi over 3 is 1/2. I'm going to put these in parentheses just so I can keep track of the signs on each fraction. So this is negative root 6 over 4 minus root 2 over 4. Negative root 6 minus root 2 over 4 as our answer. All right, and there we have it. Let's see, we have a few more here, couple of identities, and then that's it for this video. So this first one, this looks like we did one kind of like this already. Here's a sum formula for sine. So I'm going to expand that out. Sine of the first, cosine of the second, plus sine of the second, cosine of the first, divided by sine of x, sine y. Just going to leave that right-hand side the same for now. Now I'm going to split this fraction into two fractions. So I'll have this fraction and this fraction. So I have sine of x cosine y divided by sine of x sine of y plus sine of y cosine x divided by sine of x sine of y. Some of these factors will cancel. Sine of x over sine of x, that's going to cancel. And then sine of y and sine of y, that's going to cancel. So what we're left with is cosine y over sine of y plus cosine x over sine of x. Okay, I'm running out of room here, but we can see that both of those fractions are cotangents. So cosine of y over sine of y is cotangent of y, plus cosine of x over sine of x is cotangent of x, and that's what we have on the right-hand side. Just in reversed order, but those are equal to each other. Okay, these next ones are a little bit more complicated. I have cotangent of x minus tangent of x is equal to 2 cotangent of 2x. Well, we don't have a formula for cotangent of 2x that we've been over, but tangent of 2x is just, we said tangent, 2 tangent of x divided by 1 minus tangent squared of x. So if that's the double angle for tangent, cotangent is just the reciprocal. So what we're going to say this is 2 times the reciprocal, 1 minus tangent squared of x divided by 2 tangent of x. And when I distribute this 2 through, another way of doing that is just canceling out those 2's. So this is 1 minus tangent squared of x divided by tangent of x. And then if I split that fraction, I'm going to have 1 over tangent of x minus tangent squared of x over tangent of x. 1 over tangent of x, well, that's just the reciprocal of tangent, so that's cotangent. And then that second fraction, tangent squared over tangent, is just tangent of x. And that's what we have. So the thing to notice here is that cotangent of 2x, while we don't have a formula for the double angle for cotangent, we do for tangent, and so it's just the reciprocal. Okay, and then lastly, tangent squared of theta minus sine squared of theta is equal to sine to the 4th theta secant squared theta. Well, I'm going to go ahead and turn everything into sine and cosine. Tangent squared is sine squared of theta over cosine squared of theta minus sine squared of theta is equal to sine to the 4th theta times secant squared is 1 over cosine squared. Okay, on the left-hand side, I want to get a common denominator. I want to add those fractions together. So give me a little more space here. The common denominator will be cosine squared. So this is cosine squared of theta over cosine squared of theta. So keep that first fraction the same. Minus, I'm left with sine squared theta, cosine squared theta, divided by cosine squared theta. And combining those fractions, we're going to have sine squared theta minus sine squared theta cosine squared theta divided by cosine squared theta. And the reason to do that is, it's looking closer to what we have on the right-hand side, although it's not exactly the same. When I multiply the two fractions on the right-hand side, this is what I get. So the denominators are the same, but I don't yet have the numerator the same. So I'm going to rewrite this over here, and let me copy this. Okay, now one thing that we can do is in the numerator on the left, I can factor out a sine squared theta, and I have 1 minus cosine squared theta. And 1 minus cosine squared theta is just a version of the Pythagorean identity, right? If I subtract cosine squared, I'm left with sine squared theta equals 1 minus cosine squared theta. So I'm going to replace this with sine squared theta. So in the numerator, sine squared times sine squared is sine to the 4th theta divided by cosine squared theta. And there we have it.